Hey, how are you guys doing today? All right, I'm doing pretty well. Have my coffee in front of me, got ready to do some math here. And we're going to continue our conversation with solving quadratics. Last time we were solving quadratics with graphing. And today is in a very much the same manner as our last lesson that we're going to still be solving. But instead of graphing, which can take a long time and is not always exact, we're going to do something algebraic today, which is solve with factoring. Which, once again, kind of like last lesson, there's no new mechanics to teach you. We're going to really just use the same mechanics in factoring that we've talked about so far in this unit, but we're going to use it to solve, not just to factor. But just once again, to kind of review a little bit, kind of get you thinking about solutions and what solving means, got a couple of warm-up problems for you. So, and you're going to solve these by graphing just like you did in the last unit. So go ahead and pause the video. Go ahead and solve 1 and 2 with graphing and turn it back on. We'll see how you did. All right, and here we go. All right, so I have the warm-up worked here, so let's flip over and take a look. The first one, a little less work. All right, it is in vertex form, so we can see the vertex clearly. All right, so 3, -3, so that's where we're going to start our graph. We can see the a value is 3, so I'm going to go up 3 to the right one, up 3 to the left one. 3a is 9, so I can go up 9 to the right one, up 9 to the left one. We get a very clean graph there. And the nice thing is, once again, we're solving, and remember when we're solving, we're looking for, okay, where does it cross this, all right, x-axis here? All right, and we can see that it crosses at 2, 0 and at 4, 0. All right, looking at our second problem. Now, this is the one that requires us to do a little bit more work. All right, this is in standard form, which means we have to do a little bit of work to find our vertex. So we have to use our little formula to get us going, which is the opposite of b over 2a. So you can see that when we look at this, a is -2, b is 16, c is -30. So the opposite of b would be -16. 2 times a would be 2 times -2. -16 divided by -4 is 4. And then once again, we just have to plug that x value back into our equation to find our y value, and we get that our y value is 2. So our vertex is 4, 2. That's where I started our graph. All right, and then our a value is -2. So I'm going to go down 2 to the right one, down 2 to the left one. I think I did that was in reverse, but it doesn't really matter. Then we're going to go down 6 to the right one, down 6 to the left one, and then you can see that there's our quadratic this time. Now, once again, we get two solutions, 3, 0 and 5, 0. And then once again, we talked about those three possibilities last time, that we could have two solutions, one solution, or no solutions. All right, so once again, we're going to still be solving. We're going to still be looking for these x-intercepts, but we're going to do it without having to create a graph of the equation. And we're going to do that today algebraically by factoring. All right, so now when we think about factoring, all right, let me just scroll down here to the bottom of the page. All right, so remember when we're solving, right, we want one side of the equals to be 0, basically y is 0. All right, now when we look at what we have, all right, we're going to see three different types of situations. All right, so situation one is when it's already in factored form for us. All right, so we don't have to do any work, right, because it's already in our factored form that we've discussed. And then what we're going to do is we're going to use the 0 property to take each of these factors and solve. And you'll see what I mean by that in just a moment when we go through a few examples. Then, all right, what we have is standard form, right? So we have something that looks like this. All right, a could be 1, a could be another number, but basically it's in standard form. Now, if it's in standard form, that's when we have to go through our factoring. We have to do our area model. All right, we have to do a times c. We have to go through all those great things, right? We always want to look for that GCF first before we jump into that factoring, all right, before we F things up completely. All right, so that's the second thing. Now, the third thing, all right, is vertex form, all right? And that could be where we have an h value, all right, or maybe we don't have an h value, all right? And then we can just use our regular solving methods. We don't have to factor. We don't have to do anything fancy, all right? So a lot of this is really about recognizing the forms that we've talked about, right? And so the good news is, I think with standard form and vertex form, We've done a lot of work with that recently with our graphing. All right, so you should be able to recognize those two forms. To me, factored form, you'll see that in just a moment. It's a little less familiar, but after we do this lesson, I think you'll see it and be able to work with that pretty easily. All right, so let's take a look at a few examples of something in factored form. So I'm going to flip to our second page of notes here. All right, so we're going to go right here. And when you look at example 3 here, and you look at example 4, 5, and 6 here, you can see that it's all factored for us. This is kind of what we want it to look like in order to solve. All right, and so this is where we really don't have to do any pre-work to get it in this form. We can go ahead and kind of think about solving right away. Now, here's what we know, and here's the zero property, is that if this is equal to 0, and this is a product, okay, one or all of these things could be 0. So that means I take the first factor, that's x, could be 0. That means x minus 3 could be 0. That means x minus 7 could be, you guessed it, 0. All right, so there you go. And then we want to solve each individual piece here. Well, x equals 0, that means one solution is 0. X minus 3 equals 0, that means x would have to be 3 for that to be 0, because 3 minus 3 is 0. And then x minus 7 is 0, that means that x would have to be 7. And it's really that simple once it's in factored form. Now, what you're going to see is that what we're going to have to do some of the time is get it into this form, all right? And that's where the factoring comes in that we're going to do a little bit later. All right, so now let's look at number 4. Once again, I can see that it's in factored form. We have 3 things that are multiplied to get 0. So that means the first guy, x plus 2, could be 0. It means that x minus 4 could be 0. And it means that x plus 5 could be 0. And then what we want to do is, once again, just go back and solve each one of these pieces. Well, if x plus 2 is 0, that means x has to be negative 2. If x minus 4 is 0, that means x has to be 4. If x plus 5 is 0, that means x has to be negative 5. All right. And that's really how you work with factored form. So what I'd like you to do is just give 5 and 6 a shot on your own. See how you do. They're in factored form. So see if you can go through and do what I just did with problems 5 and 6. And then flip this back on and we'll see how you did. All right, so hopefully that wasn't too much of a challenge for you. But let's see. I have those already worked right here. So let me flip to the work here. All right, so you can see that our first factor is x. So x could be 0. Our second factor is x minus 3. All right, so x minus 3 could be 0, which means x is 3. So there's our 2 solutions. All right. Now, notice this one has 5x squared out front. Well, 5x squared could be 0. No big deal. X plus 2, that could be 0. X minus 4, that could be 0. Now, we have to just do a little extra solving here. So 5 times what is 0? That means 0. So that means x squared has to be 0. What number squared is 0? That would be 0. If x plus 2 is equal to 0, that means x has to be negative 2. If x minus 4 is equal to 0, that means x is equal to 4. So we get 3 solutions here. And the reason we get 3 solutions here is that this really isn't a quadratic. But we just want to kind of see what happens, because we know sometimes we have to factor out that GCF, right? So I want you to see that one. So that's really in factored form how we deal with solving. Now let's go to back to our notes and let's take a look at 7 and 8. Now, when we think about 7 and 8, now this is where we get into some of our prerequisite knowledge and some of the lessons. All right, maybe if 7 and 8 will come back here. Let's try it again. Up slowly, slowly, come back to me. There we go. And then it's gonna just keep going. All right. Okay. Maybe it'll stop eventually. All right. We'll just have to try to work with it here. Try to make it go a little higher here. All right. So now notice, now we're not in factored form. So we have to do what we know how to do to make it look like one of the prior problems. Now, remember, this is standard form. So standard form is the key to let you know that you have to F it up, that you have to factor it up. All right, and remember, whenever we're doing that, what we want to do is look for a GCF first. All right, so when I look at my first guy here, notice I have an x squared and I have an x here. So I can factor an x out of those first two terms. So I would have 0 equals, all right, and then I can take an x out. And then I get to x minus 4. And notice in this situation, this looks a lot like what we did in number 5, right? So a lot of times when you have two terms, if you factor out that x, that GCF, it's going to put you into factored form, all right? And it means that we can jump right into this a little bit easier without going through kind of that whole full mechanics, all right, of our area model to factor. So I'm going to set our two factors equal to 0, just like we did above, all right? Okay, x equals 0 just means x is equal to 0. If x minus 4 is equal to 0, that means x is equal to 4. All right, so we get our two solutions. All right, now let's jump over here and let's look at number 8. Let me see if I can do this just a little bit. Stay. There we go. Okay. All right, so now, once again, before we know this is standard form, right? We know it's not vertex form. We know it's not factored form. All right, and then now we want to look for that GCF. And I'm going to have my 0 equals here. So 0 equals. Now if I look, I can divide 2, 4, and 6 by 2. So 2 is a GCF. And if I look, I have 3 x's, 2 x's, and 1 x. So at least 1 x is common to everything. So I can take that 1 x out. All right. And now when I look at this, that leaves me x squared. If I take the 2x out of that one. Squared, there we go. And then if I take a 2x out of this, I'm left with plus 2x. All right. And then if I take the 2x out of this, I'm left with minus 3. All right. And so now what I see is, oh, now I still have this guy. It still needs to be factored. So notice on your notes, you don't have this drawn in. I went ahead and put it in just to speed up the process a little bit. But that's where you have to recognize, okay, quadratic, I need my area model. I know my A term goes here, right? So we're going to put our x squared up here. We know our C term goes here, all right? I know I have to do A times C, so I need to multiply that, and it's negative 3. And I know I always have to add to be my B term, and my B term this time is a positive 2x. All right, now, so I need to find the factors of negative 3 that add to be positive 2, and that would be 3 times negative 1. And then 3x plus negative 1x would be a positive 2x. So I'm going to drop that positive 3x in here. All right. I'm going to drop that negative 1x in here. And now we're going to go through the factoring model that we talked about last time. I'm going to find my GCF in the first column, which is just an x. All right, I'm going to find my GCF in the second column, which is a positive 3. Find my GCF in my first row, which is an x. And then in my GCF in my second row here is going to be negative and then just 1. So now when I come back over here to my solving, I have 0 equals, and I have 2x. So remember, we always have to take that GCF and bring it down, and then I have x plus 3 and times x minus 1. All right, and so now we have to take each of those factors and set them equal to 0 and solve. So that means I'd have 2x equals to 0, and then I'd have x plus 3 equals to 0, and then I would have x minus 1 is equal to 0. And then I just have to go back through and solve for those values. So 2 times what is 0? That means x has to be 0. What plus 3 is 0? That means x has to be negative 3. All right. What minus 1 is 0? Would be 1. So that means our last solution here is 1. And so you can see we're really just reusing those skill sets, all right, with factoring that we've talked about. All right, so once again, I want you to do some on your own now. So try 9 and 10 on your own. All right, pause the video. All right, turn the video back on to check your work. Or if you wanted to download the complete notes, right, they're already worked out for you. You can see all the work as you go and check it step by step if you want. All right, but go ahead and try 9 and 10. All right, so let's see how you did. Now, once again, I've done the work for 9 and 10 separately, so let me flip over to 9 and 10. All right, and you can kind of see the work. Now, both problems have a GCF that you should start by taking out. So on problem 9, our GCF is a 2, so I took my 2 out. That left me x squared minus 6x plus 5. And we can see that this is in standard form, so I'm going to go to my area model, x squared in the upper left, 5 in the lower right. A times c is 5. And I have to add to be my b term, which is negative 6. So negative 1 times negative 5 is 5. Negative 1x plus negative 5x is negative 6x. You see I drop those in here. Our GCF here is x. Our GCF here is negative 1. Our GCF on our first row is x. Our GCF on our second row is negative 5. So now when I go back and plug those in, I get 2 times x minus 1 times x minus 5. Now, notice this time our GCF is just a 2. We don't really have to worry about that because 2 can never be 0, so we don't have to solve that part. But then we have x minus 1 is 0 and x minus 5 is 0, which means x could be 1, x could be 5. So we get 2 solutions. Now on number 10, we have a GCF of 3x cubed. All right, so you can see that I took 3x cubed out front, which leaves us the quadratic x squared plus 8x plus 15. So once again, jumping back into our area model, here is x squared. All right, here is 15. All right, so a times c is 15, and then I have to add to be my b term, which is 8x. So the combination I want this time is 5 times 3, which is 15. And then 5x plus 3x is 8x. So I'm going to drop the 5x here, the 3x here. The GCF in that first column is x. GCF in the second column is 5. GCF in the first row is x. GCF in the second row is a positive 3. And so you can see that here are my 3 factors. 3x cubed times x plus 5 times x plus 3. So we want to take those 3 factors and set them equal to 0. So 3x cubed equals 0, which means x cubed is equal to 0, which means x has to be 0. X plus 5 is equal to 0, which means x is equal to negative 5. X plus 3 is equal to 0, which means x is equal to negative 3. All right, so once again, you can just see reusing a lot of our skill set. Now, for the last little bit, all right, that we have to do here. So notice, when we go back here, and let me flip back to our notes, right? So what we said is that we always want one side of our equation to be equal to 0. And we've talked about that when we solved this year, right? That we always want it equal to 0. Well, when you look at, all right, some of our problems, let me see, and it doesn't want to go down now. There we go. All right, so when I look at 11 and 12, all right, what you're going to notice is that problems don't always have to start equal to 0. Sometimes we have to make them equal to 0, which really isn't a big deal because we've been doing that when we've solved a lot this year anyhow. All right, so when we do this, if it's not equal to 0, all right, equal to 0, I can just jump into my process. Equal to 0, jump into my process. Not equal to 0. All right, so what I have to do now is make it equal to 0, and then it's just really the same steps. So I'm going to add 63 here. And remember, it doesn't matter which side you make equal to 0. Just pick the easiest side. So I'm going to add 63 to both sides here. Now, what I want you to notice is that when I add 63 to both sides here, all right, maybe that'll stop. There we go. All right, I have 7m squared. All right, plus 42m. And then plus 63. Now, these are not like terms, right? An m squared, an m, and a number, so I can't put any of those together, so I have to write them all in separate columns. And so notice, I just had one additional step on this problem to make it just like what we did before. All right, so now, once again, now it's equal to 0. I'm going to look for my GCF, which in this case is a 7. All right, so I'm going to take a 7 out here. All right, and then if I take that 7 out, that's going to leave me m squared plus 6m plus 9, and that's equal to 0. All right, and so now once I have that GCF out, I'm ready to jump into my area model to factor. So m squared is going to go up here into the upper left. All right, I'm going to get a plus 9 down here. All right, so A times C is 9. And we know we have to add to be our B term, and our B term is a positive 6m. All right, so the combination we're going to want this time is 3 times 3 is 9, and 3m plus 3m is 6m. And so we drop those guys in here, drop that guy in here. All right, so if I look at my GCF in that first column, it is an m. Yes, our GCF here is a positive 3, so I'm going to take that guy out. Our GCF in our first row is once again just an m. Our GCF here is a positive 3 again. Now this leads us to a different type of situation than maybe we've seen before, because notice I'm going to have 7, and then I'm going to have m plus 3 times m plus 3, right? And then that's all equal to 0. Now once again, notice I have this 7 out here. 7 can never be equal to 0, so I don't have to worry about that. But I get m plus 3 is equal to 0, and I get m plus 3 is equal to 0. And so notice, this would mean m is negative 3. This means that m is also negative 3. So I get the same solution twice, which really means we're in that situation. Oh, I'm not sure what that was right there. Why I got all wiggly there. All right, maybe, there we go. All right, I don't know why I wanted to erase everything there. All right, but so what this means is that we get the same solution twice. And that really means we have just one solution. That means that the vertex, all right, of this quadratic that we solved is sitting on the x-axis. And the fancy term for this is multiplicity. All right, you'll learn a little bit more about that in Algebra 2. All right, I think what I want to do here, since we're getting a little late in the video, all right, is don't worry about number 12 right now. If you want to go back and do that on your own later, go ahead. What I'd like you to do now is just go ahead and flip, all right, to our next page of notes here. And I would like you to go ahead and try problems 13 and 14 here. Okay, so go ahead and try 13 and 14. Pause the video, check your work, all right, by turning the video back on or with the fully worked notes, and then we'll move forward. I have some coffee. All right, so let's take a look. Once again, I have everything worked out for you. All right, so notice in both of these, you had to get them equal to 0. So on number 13, you can see that I added 4 to both sides, right? So add 4, no like terms here, so I'm bringing everything down. 6m squared plus 14m plus 4 is equal to 0. Factor out a 2, all right, that's our GCF. So I'm left with 3m squared plus 7m plus 2. So I drop my a term into the upper left, my c term in the lower right. Now a times c this time, so 3 times 2 is 6. And I have to add to be my b term, which is 7m. So the combination we want this time is positive 1 times positive 6. Positive 1m plus positive 6m is 7m. So we place 1m and 6 in here. Now, when I look here, my GCF in my first column is 3m. My GCF in the second column is plus 1. My GCF in the first row is m. My GCF in the second row is 2. So when I rewrite my factors, I have 2 out front. 3m plus 1 times m plus 2. Now, once again, 2 can never equal to 0, so we don't have to worry about that. But 3m plus 1 could be 0, or m plus 2 could be 0. Well, if 3m plus 1 is equal to 0, that means 3m is equal to negative 1. I can divide both sides by 3, and I get m is equal to negative 1/3. Now, if you want to do this on your calculator, you would get like negative 0.3 or 0.33. That's equivalent. That's fine. You may express it either way. Now, notice on 14, you had to move 2 terms. Now, I typically want my x squared term to be positive, so I moved everything to the left side. It does not matter, all right? It does not matter at all, right? But I subtracted 8 and I added 3x. Now, notice over here, there is no x term, so I'd have x squared, I'd have the positive 3x, but 10 and negative 8 are like terms, so I can do 10 minus 8, which gives me positive 2. And then you can see that we are right back into our area model here. So x squared here, 2 here. A times c is 2. All right, a times c is 2. Our b term is 3x. All right, so now 1x plus 2x is 3x. All right, so that's the combination that we want here. So that gives us a factor of x plus 1 and a factor of x plus 2. So x plus 1 equals 0 gives us x equals negative 1. X plus 2 equals 0 gives us x equals negative 2. So there is all the work, and really working with standard form is really the longest of the process, just because there's a lot more steps involved. Now, if you look at, all right, some more of the examples here, all right, I'm going to look at 15, 17, and 19 here maybe as they scroll by. Let me see if I can scroll up just a little bit here to get them here. Now, notice all of these have one thing in common. So when I look at them, notice there's no b term. All right, so I don't see any x terms. I have x squared terms, right, and constant terms. Now what that means is that we can just do our regular solving process. We don't need, all right, we don't need to go through factoring. We don't need to do any of that work. All right, we can just go right to what we've talked about this year with our solving process. All right, so when I look at this, once again, we always want one side to be equal to 0. All right, and so now 0 equals x squared minus 1. Well, that means that x squared has to equal to positive 1. And then I can take the square root of both sides. Now, what we have to remember, all right, is that my calculator is only going to give me positive 1. So if I come over here, I'll show you how to do this on your calculator. So the square root is this blue right here above the x squared key. So I have to hit second square root of 1. And then when I hit enter, it's only going to give me the positive root. And so what we talked about is I have to remember that, okay, that really means that I'm going to get 1 and negative 1. But your calculator is only going to give you the positive root. All right, so now when I look at 17, all right, it's equal to 0. Now, what we talked about is using that 0 property. Well, what plus 420 is 0? Negative 420. So I know 10 n squared has to equal to negative 420. All right, and then I can just divide by 10, divide by 10. All right, and that means n squared would equal to negative 400 and, or not 420, but just negative 42. Now, I'm going to take the square root. Now, if you do this on your calculator, all right, so if I go back here to do second square root and I do negative 42, right, notice what my calculator tells me, non-real answer. So what that means mathematically is then we're in that situation where it does not cross the x-axis. So if you don't recognize it here, your calculator will tell you something's not right. Okay, and so what this is telling us is that there is no solutions for this one, all right? All right, so we've seen that before with a lot of our work this year. All right, so looking at 19. Okay, so here we go. All right, so we need to make it equal to 0. So I'm going to subtract 284 and subtract 284. Now notice there are like terms over here, so I'm going to try to line those up here. All right. All right, my pen is starting to slow down here. So 8x squared minus 288 is equal to 0. All right, so that means that 8x squared is equal to 288. All right, that means divide by 8. Divide by 8. That means x squared is equal to 36. All right, and if I take the square root here, take the square root here, that means x is going to be 6 and negative 6. All right, so we're getting close to that 30-minute mark. This has been a really, really long lesson. A lot of information, but a lot of review in it as well. So here's what I'd like you to do. Instead of me droning on here, I would like you to try 16, 18, and 20, all right, on your own. I want you to pull up the fully worked note sheet, check your work against those, and then I want you to try 13, 14, and 15 here. I'm not sure why I didn't number these correctly. It should be 21, 22, and 23. Not sure what happened. Maybe working too early, not enough coffee, staying up too late, watching Star Wars and those kind of things. But try these 3 problems on your own. I'll give you a hint. All right, well, for 14 and 15 here, you have to get them equal to 0, which 14 is, and then you have to factor by grouping. All right, my friends, sorry it ran long today. All right, hope you're doing well. Hope things are good for you. Hope you're somewhat enjoying this time. All right, once again, if you have any questions, email us, get on the Google Hangout, chat with us a little bit. We'll help you out. All right, have a great day, and I'll see you next time.